Hello everyone, how are you doing today? I trust you're having a wonderful day. In today's class, we'll be talking about the third security domain, which is security architecture and engineering. In the last class, we discussed asset security and also the first domain, security management and risk. What you should know is the eight domains in cybersecurity talks about the eight pillars of cybersecurity, the main concepts and the different aspects of cybersecurity. So you can delve into any of these aspects of cybersecurity. Domain 3, which is security architecture and engineering, talks about the foundational principles and practices for building a secure system. Remember, all that we're trying to do in cybersecurity is to bring out the core concept, which is the CIA triad. That is confidentiality, integrity, and availability of information. Remember, confidentiality means keeping information secret and confidential so that only the authorized people or persons is able to access it. And you think about things like encryption, access controls, and data classification. Encryption means the data is being encrypted from a plain text into a ciphertext. We'll talk more about that in subsequent classes. So it means whatever is written in a plain text will be converted into a ciphertext or a different text from the main text, which looks like gibberish or looks like nonsense, but the other party receiving the text, the ciphertext is converted back to real text so the person can be able to receive the information. Integrity talks about ensuring that data is accurate and not tampered with. The data is not edited, modified, or any form of modification has gone on the data. So this thing also, we are looking at signatures here, digital signatures. Digital signatures talks about a signature to confirm that the authorized person is the one in charge of the data. No one else can manipulate or edit it. Availability means the systems are available when needed and only to those who are authorized to receive it. No matter how confidential your information is and no matter how much of integrity it has, if it is not available when you need it, then it becomes useless. So think about your banking data. If you have a banking app, a popular app in Nigeria, maybe like a fintech, OPay, you are sure it is very confidential, you are sure it has integrity, but imagine that you can't access it based on network downtime or based on some other things. No matter how confidential security wise the data is, once you cannot access it, you can't log in, it becomes useless. So no matter how confidential and how much resources is put in integrity by a company, the most important factor for the end user is that the data is available when I need it. I want to have access to my data when I want to buy a recharge card. I want to have access to my data when I want to buy make a payment, maybe over the counter. I want to have access to my data when I need it specifically for some basic things. So once it is not available, the whole essence of security is actually wrong. So one of the things we look at here is security models. Security models talks about the framework, guide, and other basic principles that guide security architecture. The first one we look at is the Bell LaPadula. So they call it Bell LaPadula. The Bell LaPadula focuses on confidentiality. It was one of the first models that was released, and the concern is about keeping information secret It was first used in the military and in governments to keep classified information very secret. Then after that, there was a move to the Biba model. The Biba model focuses on integrity to avoid data corruption or data misintegrity. So the Bell-LaPadula model didn't focus on integrity, whereas the Biba model did not focus on confidentiality. So it was still missing some very basic key. Now we go to the Clark-Wilson model. The Clark-Wilson model does a balancing on confidentiality and integrity, but it still didn't answer the full question, which was about availability. Alright, now we look at security architecture. This is an high-level design of secure systems. We'll be looking at defense in depth, least privilege, separation of duties, and fail-safe default. First, let's look at defense in depth. This is talking about building multiple layers of security controls. So when one fails, another one will take over. We're looking at the least privilege principle. That one deals with giving the users only the minimal privilege they require to do their work. So if it is a staff, let the staff have the minimum requirement to do its job. As a user, the user should also have privilege to only his dashboard and what he needs to do his job. And that's very important. We'll talk about separation of duties also. This talks about dividing sensitive tasks among multiple people. So one way to reduce fraud is to divide a very sensitive task among various people. So if it takes one person who is in charge of everything, then it means the hacker knows, or the bad guy knows, or the threat actor knows they only need to break the account or hack one person and the company is in problem. But if sensitive data is in the hands of 10 people and they all need to agree before the system is broken, that might be a very difficult task because it knows he has to find who the 10 people are and he needs to also hack these 10 accounts. So that is also a way to prevent risk and prevent the company from being hacked. Let's look at the fail-safe default. Well, systems should be able to return back to a secure state if something goes wrong. So it's more like we are reverting back to default mode. So if everything goes wrong or something goes wrong, there should be a restoration back to controls in depth. In security controls, there are three basic types. There is the technical control, there is the administrative control, and there is the physical control. Technical controls talks about using things like firewalls, and when we mean firewalls, it's more like a wall of fire, like a biblical wall of fire. So it doesn't mean there is fire on the wall. What it means is that it's more like prevent unauthorized traffic from coming in and from going out. We also have IDS, intrusion detection systems, that detects whatever is not right with the network or with the system. So there should be IDS in place to block traffics that are not right or are not authorized. They also have antivirus softwares. Antivirus softwares can also help to prevent your systems from being hijacked by viruses, malwares, and other forms of softwares that can harm the system. Administrative controls talks about policies, procedures, and awareness given by the company. So, as a cybersecurity analyst, you should be able to work with the policies the company has in place, maybe the framework the company is using, whatever it is, and the procedures. So every company should have basic policies that they should be able to let their staff know about, and it should be very easy to understand, a very easy guide also. Basic policies like you don't use weak passwords, policies against weak passwords. They can also set standards where passwords have a required number of digits, maybe 12 digits. Then the number of characters you can have, a combination of numbers, letters, alphabet, whatever characters could also be very helpful in preventing the company from being hacked by the bad guys. You can also have policies like don't plug in any software, or don't plug in any device that is not authorized by the security team or security engineer or whatever who is in charge. So it should be a policy that you shouldn't plug in any form of software that is not authorized, or plug in any form of device that is not authorized. So there are many policies a company can put in place to be able to prevent or mitigate risk. Physical also talks about locks, like physical locks, security doors, and security cameras like CCTV cameras, and all of those things can be a physical lock. Then we'll look at cryptography. Cryptography talks about encryption. Encryption, like I said, it transforms a real data numbers like my name is David can be converted into nonsense or unreadable format. And we'll still talk about this in software classes. So my name is David can be converted to something like the BDEEABBBB, something that it is completely unreadable and senseless. But the person receiving that will have a key to be able to unlock that into a readable format. That's one form of encryption. Then decryption talks about that data that actually been encrypted can be turned to a real readable format by the person who's supposed to handle the data. So this one, you also look at things like public key infrastructure. Public key is for ensuring the authenticity of any message sent, giving a certificate to every message sent to show that it is from the right authority or the right source. Now we can look at vulnerability management. Vulnerability management talks about finding weaknesses in your software, and this should be done before the attackers can be able to exploit it. So you can do a testing your own self, a scanning yourself, penetration testing before the bad guys come in and do the testing. You should do a security audit on your own regularly. As a security analyst, work with your team to do a security audit. So there should be a proactive threat hunting issue. Before the bad guys come and do it, you test your system first to see that it is free of any form of vulnerability. Remove vulnerability when we talk about leaks, old softwares, or whatever it is that the bad guys can use to exploit and come into your system and plant malicious softwares and other things like that. We talk about security assessment. There should always be a proper assessment of your system. You should look at different forms of assessment, testing continually to see your system is completely free from all forms of attacks, and properly follow the incident policy that your company has, the incident management policy, whatever it is that they have to rescue the team in the place of an incident, and in the place of a breach. So I believe this class has been helpful for you. If you have any questions, drop in the comments and also ask in the class. Thank you, and join me in the next class.